Welcome to this session on Kubernetes storage, part of Certified Kubernetes Administrator exam preparation. In this video, we will break down storage concepts step by step so you can master them for both the exam and real-world Kubernetes work. The Certified Kubernetes Administrator or CKA is a certification created by the Cloud Native Computing Foundation and the Linux Foundation. It validates your skills in designing, building, and managing highly available Kubernetes clusters. Here's what you need to know about this exam. It is a performance-based exam, so you solve real tasks in a terminal. The duration is 2 hours, fully proctored online. It tests hands-on knowledge, not just theory. And importantly, there are no prerequisites. This means anyone ready to learn Kubernetes deeply can attempt it. Now, various domains are covered in this certification, which are flashed on the screen. This includes storage, troubleshooting, workloads and scheduling, architecture and installation, and finally, services and networking. Coming to the first domain, that is storage. In this storage domain, we will explore different volume types, access modes, reclaim policies, persistent volumes and persistent volume claims, storage classes, and dynamic provisioning. These concepts form the backbone of Kubernetes storage management. Before we start, let's see this diagram. In Kubernetes, a pod is basically a collection of two things, the container and the volumes. Volume can be defined in pod's manifest like empty dir and host path. But to make the application portable, we need to decouple their storage needs from the pod itself. That's where Kubernetes gives us flexible options. Here how it works. You can use site-specific persistent volumes or enable dynamic provisioning for flexibility. A persistent volume claim is the API resource that binds a pod to the storage. When a PVC is created, Kubernetes checks if a matching persistent volume already exists. If no matching persistent volume is available, a storage class steps into the provisioning the storage automatically. This is powered by a storage provisioner, which creates the persistent volumes on demand. In short, the architecture ensures that the storage is decoupled, portable, and scalable. Now coming towards the volumes. Volume provide a way for container in a pod to access shared data via file system. Kubernetes volumes solve two major problems. The first is persistence, which is data can survive even if a container crashes. The second is sharing, which is multiple container in the same pod can share the same files. There are normally two categories: ephemeral volume like empty dir, which exists only while the pod exists, and which is deleted once the pod is deleted, but it has no effect if the container crashes. The second is persistent volume, which are independent and survive beyond the pod lifecycle. Another useful option is host path, which mounts directories or files from the host machine into the pod. It is not treated as ephemeral storage, as data persists even after the deletion of the pod. Now let us take a look into the YAML file. The first pod uses empty dir. This gives all container in the pod a shared temporary directory at as defined here /cache. The data is deleted when the pod is deleted. The second example uses host path. Here directories and files from the host file system are mounted into the pod. This data survives even if the pod is deleted, but the downside is it ties your pod to specific node. And there is also a security risk in accessing the file system of the node itself. Now coming towards the demo. Now I have two files already, the manifest with me. The first one is empty dir. You can see it is defined in the manifest of the pod and is mounted as a volume, and the size limit is also defined. Now let us create this pod. You can see the pod has been created. Now the mount path was empt dir example. Let's see if we are able to create any file in this particular directory. Let us first find the directory. As you can see, the mdir example directory has been created. It is shared by all the containers in the pod. As you can see, we can use this directory and create a file. And if there is some other container in this particular pod, they can access this file as well. Now coming towards the second example, which is the host path. As you can see, the mount path is /local, and the mount path for the file is /local/1.txt, and it is mapped to the var/AAA directory and AAA/1.txt. Now creating the pod, as you can see, the pod has been created on node 0.1. Now, as we can see that there is no directory created on the control plane or the control node. The directory will be created on the node 0.1 because the pod is scheduled on the node 0.1. As you can see, the AAA folder is there in node 0.1. Now let's go inside the pod and make some changes in the 1.txt file, and let's see if these changes are reflected in the node 0.1 as well. As the mount path was local, so we have the file in the local directory. Now let us write the Kubernetes in the 1.txt, and let's see if this is replicated or it is reflected in the node 0.1 file system as well. Here you go. The file system of the node and the pod are related to each other. Now moving towards the persistent volumes and claims. For long-term storage, Kubernetes provides persistent volumes and persistent volume claims. A persistent volume is a cluster resource that abstracts the detail of storage, whether it's local disk, NFS, or cloud storage. A persistent volume claim, or PVC, is how a pod requests storage. The provisioning can be static, where admin manually creates the PVs, or dynamic, where a storage class automatically provisions storage whenever a PVC requests it. Now let's have a look of the YAML file. First of all, the persistent volume. The capacity here is 1 gig. The access mode is read write many, so multiple nodes can use it simultaneously. And the reclaim policy is retained, meaning the volume isn't automatically deleted when released. In order to use the storage, manual reclamation is required. The other reclaim policies include recycle, which wipes the data that is basic scrub of rm-rf, and delete, which removes the resources or the volumes entirely. Then there are access mode. The first one is read write once, which is the read and write by a single node. Read-write many means the read and write by many nodes. And read-write once pod, it is the read and write by a single pod. This gives admin fine-grained control over how storage is reused. Now coming towards the persistent volume claim manifest file, there is a YAML file. It asks for 1 gig of storage and read-write many as the same. It should match with the persistent volume. So when a PVC matches a persistent volume, Kubernetes automatically binds them together. From the pod's perspective, it simply mounts the PVC at a directory like /data without needing to know anything about the underlying storage system. This abstraction makes your application portable across the environment. Now coming towards the live demo. I already have the complete file in which we have a persistent volume. Here we have defined the path /data, the host path. So it is on the, it will be reflected on the file system of the node. Then we have the persistent volume claim that matches the requirement of the persistent volume. And then we have a pod in which the persistent volume claim has been defined. Now let us create this file. The three resources have been created. The first one is persistent volume, then is persistent volume claim, and then the pod that actually uses the persistent volume claim. Now, as we see that the pod has been scheduled on node 01. Let us create a file in our pod and let's see if it is reflected or the same configuration is reflected in the node 01 as well. The mount path was /pod/data, and now let's see the node 01, and in the file system we can see that it is reflected in the data folder and test.txt has been created. Now moving forward, we come to the storage classes and dynamic provisioning. Storage classes bring automation in the Kubernetes storage. They allow admins to define multiple classes of storage, for example, high-speed SSDs, encrypted storage, or storage with backup policy. When a PVC doesn't find a matching PV, Kubernetes uses the storage class to dynamically create one. You can also configure a default storage class, so any PVC without any explicit class gets handled automatically by the default storage class. Now here's the YAML file. Its name is low latency. The provisioner defines which volume plugins will be used. The reclaim policy is set to retain, though the default one is delete. The volume expansion is enabled. It means that the volume can grow in size, but it cannot shrink in size. Then we have mount option and topology constraints can be set for the performance and the location control. These are the provider specific requirements. It is marked as default, so this storage class will be used for all PVC that don't specify a class. Now coming towards the live demo, I have created a single file for storage in which I have defined the storage class. The name is custom local path. The storage class is used as a default. It is true. The provisioner is the one that is shown, and the bind is for wait for the first customer. It means that when the pod is created, only then the volume will be binded to the pod and the volume will be provided. Then we have persistent volume claim configurations, and then in the pod we have defined the persistent volume claim. Now when we create this file, you can see the pod has been scheduled. let's see the persistent volume claim, and it has been bounded, and it is bounded to the storage class custom local path, which is the default the storage class that we have defined. In this example, we didn't define the persistent volume. The volume is automatically assigned, dynamically provided through the storage class that we have defined, which has the same configuration that was asked by the persistent volume claim, and it is bounded to the particular pod. Now, to summarize, the pod volume handle temporary or host specific data needs. Persistent volume and persistent volume claim provide a long-term reusable storage. The storage classes enable automation and flexibility for storage provisioning. Mastering these concepts is critical for both the CKA exam and real-world Kubernetes administration. If you found this video helpful, don't forget to like, share, and subscribe for more Kubernetes tutorials. And let us know, and let's continue this learning.